Okay, so much of what we've been trying to do in this chapter is to solve quadratic equations, which if you forget, quadratic again just means an x squared equation. And generally, quadratics are going to have two answers, all right? But sometimes they can actually be imaginary answers. All right, so that's what we're going to do today is we're going to solve in quadratics, but we're going to have answers that have I in them imaginary. As always with solving a quadratic, we've got these different methods we've been talking about in this chapter. So pause the video and see if you can think about which method might make sense here. And then you could actually even try it if you feel super confident in solving this one. All right, so the trick on this is if it has no x part, right? It just has the x squared, then we can use algebra steps. So all that means is I just do what I normally do. So minus 32 from both sides, divide by 2 to get x squared alone. And then we can cancel out the square by doing the square root. Okay, and right, we got negative square root over here. So basically, the square root of 16 is usually 4, but the square root of negative 16 then is just going to be 4i. All right, and don't forget, right, that there's two answers. So my answer here when I take the square root is actually both plus and minus 4i. So we have two imaginary answers, positive 4i and negative 4i. All right, let's have you try one here quick. Pause the video, see if you can solve this one. Okay, so when you're solving a quadratic, again, if there's no x part, you can just do the algebra steps. So minus 15, okay, and then take the square root. And then all that's really different here is it doesn't come out nice and neat. So we've got to do our simplest radical form. So for 15, I'm going to split the negative part off, and that's going to become I. And then 15, there's no perfect squares that divide 15. So my answer here is just going to be plus or minus I and then square root 15. And those are my two solutions to that quadratic equation. Okay, I had one more here I just wanted to blast through that just has fractions, so it's a little goofy on this one. So if we were solving on this one, add 3, divide by negative 4, so we get negative 3/4. Okay, and then this gets a little goofy when we do the square root, because we're doing square root of a fraction. But basically, if you just want to pull the I in front for the negative square root and then just leave it as square root of 4/3 with a plus or minus. So I think that might come up in the homework or something. So maybe that's why I put it in here. But at any rate, just if you have a fraction, just leave it like that. It's okay for now. Okay. So now we're going to try solving one that's a little bit trickier because now we have both x squared and x. So our algebra steps is out. Okay, we could think about factoring it, but we'd have to do that long factor where we go like 2 times 5 and all that stuff. So I'm going to throw out factoring. Okay, and graph method is one of my favorites, right? Is just set it to 0 and graph. So I'm going to try that quick here with Desmos. So you can see like the flaw in the graph method here, right? So remember graphically, our solutions are where it crosses on the x-axis. So this one doesn't cross at all, meaning our answers are not real answers, but imaginary. Okay, so that basically means graphing is now out, and factoring, even if we try to factor, it won't work. You can't get imaginary answers with factoring. Okay, so that's not going to work. And in fact, the only two methods that are going to ever work for imaginary are algebra steps, which we already did a couple examples of those, and then quad formula can always get you the answers. It's a default, will solve every single quadratic, including ones that have imaginary answers. All right, so if you want to try your formula here, it'd be a great time to pause the video and see if you can do it with simplest radical form and all the imaginary stuff. All right, hopefully you had a chance to try it. A is 2, B is negative 3, and C is 5. So I'm going to write out my big formula here. I'm going to do the opposite of B, plus or minus square root B squared minus 4 times A times C. That's one giant check mark all over 2 times A. All right, and I always do this little check mark off on the side. So negative 3 squared, make sure you have the parentheses there. 4 times 2 times 5 is 40. 40, I wrote 20. That's awesome. So I can write the right number there. 40. Okay, and then we're going to subtract 9 and 40, so that would be negative 31. And so here's where the imaginary comes in. Right, we got a negative square root. So we're just going to clean this up, do our simplest radical form. Hopefully you've got good practice with that at this point. There's no perfect squares for 31, so I'm going to pull off just the negative part. And so I end up with like I and root 31. And again, usually the I comes before the root. Okay, so plugging that back in, see what we got here. So we got x equals 3. Sorry for the struggles there. 3 plus or minus that whole check mark, which was I root 31, all over 2 times 2, 4. Okay, and that's it. This 4 doesn't evenly divide up here, and there's no other way to simplify the radical, so that's it. It's kind of a weird way to leave your answer, but that's actually our two answers. It has a plus minus in it, so 3 plus I root 31 over 4, and 3 minus I root 31 over 4 are our two answers. And you can just leave it just like that. It's just fine for writing your answers. All right, try to solve this one. Pause the video, give it a shot. So when I first looked at this, I thought, this certainly looks like it factors maybe. Like I could just do x and x and then, multiply to positive 5 and add up to negative 4. But for positive 5, it'd have to be either positive 1 and positive 5 or negative 1 and negative 5, and neither of those will add up to the 4. So it looks like it actually doesn't factor. And again, if we were to graph it, it wouldn't cross the x-axis. So this one, our only hope is quad formula. All right, so it should have imaginary answers. If you graphed it, you'd see it would not cross that x-axis. Okay, so here I go on my formula. I'm going to do the opposite of b, plus or minus square root b squared minus 4 times a times c. I don't know why I never make my check mark big enough. You think I'd figure it out. All over 2 times a. Come off to the side, do our check mark, also known as radical. Negative 4 squared is 16 minus 20. Ooh, this one's a little more exciting. We get negative 4. And so this is kind of nice because 4 is a perfect square. So we're going to get 2i. Okay, then we're going to plug it back in. This one's going to clean up a little bit prettier. So we're going to have 4 plus or minus the radical, which is 2i, all over 2. And then, ooh, look at how fun this is. This 2 evenly divides the top part and the bottom. Sorry, not the top and bottom, the 4 and the 2i. So I'm going to divide it out and actually write it as 2 plus or minus I, 1i essentially. All right, and that's my two answers, 2 plus I and 2 minus I. So it might be different each time, right? Like on this last one, the 4 didn't divide evenly, so I didn't divide it out of the parts. On this one, it did, so it makes sense to clean it up one step further to this final answer that's written there. Okay, and that's it. So we were basically solving, right, with imaginary numbers, right? And there will only be two methods. On this one, you could use algebra steps to solve that one because there's no x part. And then on this particular one, if it doesn't factor and the graph method doesn't work, so we could get 0 on one side, try our graph method and stuff. But if it doesn't factor and the graph method's not going to work, then we have to find imaginary answers using the quad formula. Right? Quad formula is our default method that'll solve any quadratic. And so when you find imaginary, sometimes you'll use quad formula and sometimes you use algebra steps. Right? So that's it. That's kind of part of the reason why we did all this imaginary numbers, was to help us solve x squareds that have non-real answers, have imaginary answers. So hopefully all that kind of came together, the quad formula and imaginary numbers, and now we're able to solve x squareds with imaginary numbers. All right, that is all. Have a good day.